All right, for our last part here, the biggest issue is a lot of multiplication. So again, we're going to structure it. You only got 10 problems this time, so it's a little bit quicker to complete. But again, trinomials are multiplying by another trinomial, which means a lot of boxes that we need to structure. Still going to be careful with our signs. I'll help you with 2 problems, and then you'll try the remaining on your own. Again, only total of 10 for this assignment for our last part of the day. All right, so for on number 1, let's go ahead and again structure our new box. Since it is a trinomial multiplied by another trinomial, that means we need to adjust our box creation further. So we're going to go ahead and have 3 vertical and 3 horizontal. Three vertical, 3 horizontal. Dot in the corner. And then once you have your graphic organizer structured, we go ahead and start putting our items, our terms, where they belong. So at the top again, from trinomial 1, we've got 8x squared, positive 6x, negative 7. On the left is our trinomial 2, 5x squared, positive 7x, positive 7. So if you notice, most of it is positive, so it's generally a little bit easier. Once you have it structured, then you start your multiplication. Now remember, the hint is still the same. The first term and the last term need to look completely different than everything else. So be very careful on the first box with your variables. 5 times 8 is 40. X squared times x squared is x to the 4th. 5 times 6 is 30. X squared times x is x cubed. 5 times negative 7 is negative 35. X squared tags along. All right, we continue with our multiplication. 7 times 8 is 56. X times x squared is x cubed. 7 times 6 is 42. X times x is x squared. 7 times negative 7 is negative 49. X tags along. Last row, 7 times 8 is 56. X squared tags along. 7 times 6 is 42. X tags along. Last one, 7 times negative 7 is negative 49. All right, if you notice, we got quite a bit here. So starting off, 40x to the 4th stays the same. Then we look at our x cubes. Now, if you notice, they're both positive, which means we just add them together. 56 plus 30 is 86. X cubed stays x cubed. Don't try and combine those. All right, the next one, a little bit more challenging without the calculator, but we're going to add and then subtract 35. So we're just going to combine everything. So let's see, off to the side maybe. 56 plus 42, that's going to be 98. But then we got to subtract 35. So again, if you don't have a calculator, 8 subtract 5 is 3, 9 subtract 3 is 6. So that's positive 63 x squared. And then for the x's, 42 subtract 49, or 49 subtract 42, keep the negative sign, is negative 7x. And the last one is negative 49. So again, a lot more work involved there, but you only have a total of 10 problems. I'm going to help you with 2. Let's see if we can find another one that has a lot of negative signs, because again, those are the ones that are a little bit more challenging. If everything's positive, definitely easier. It's just a multiply and then a lot of adding. But again, we need to structure a 3x3 chart. Ooh, that one. Look at us do this one. Number 2, definitely. Numbers aren't going to be too big, hopefully. We got a bunch of negative signs there. So for our last one to help, let's go to make our 3x3 grid, our structure. And that's because we have 3 terms in our first parentheses, because it's a trinomial. And then 3 terms in our second parentheses, which is also called a trinomial. Again, it's really just a fancy way of doing distributive property and combining like terms. I really like this method just because it keeps it organized very well. Students have less chances of making mistakes if they actually follow the graphic organizer. The traditional method is just doing a bunch of arrows and then things just get really cluttered. All right, so for our last one, let's see here. 5n squared, negative 4n, subtract 7. Second trinomial, 2n squared, positive 2n, negative 2. All right, here we go. Just a bunch of multiplication. 2 times 5 is 10. N squared times n squared is n to the 4th power. 2 times negative 4 is negative 8. N squared times n is n cubed. 2 times negative 7 is negative 14. N squared tags along. Do the same thing. What do you notice? It's multiplying by 2 again. So the only thing that's going to change is our variables. 2 times 5 is 10. N times n squared is n cubed. 2 times negative 4 is negative 8. N times n squared. 2 times negative 7 is negative 14. N tags along. What do you notice? The last one's multiplying by 2 as well. But there's no variables, and it's a negative 2. So again, we're just going to be careful there. So let's see. Negative 2 times 5 is negative 10. N squared tags along. Negative 2 times negative 4 is positive 8. N tags along. Negative 2 times negative 7 is positive 14. All right, now we're ready to combine like terms. Remember, first term stays exactly the same. Looking at the cubes, we just have a 10 subtract an 8. Oh, that's pretty easy for us. Positive 2n cubed. The n squareds, okay, they're all negatives, which means they're all going to be added together. A 10 and an 8 is an 18. So I really have an 18 and a 14 that I'm adding together. But remember, it stays negative because we're combining all the negatives. So 8 plus 4 is 12. 3, so negative 32n squared. Now, occasionally you might be lucky enough, let's say that it's a negative 10n squared and a positive 10n squared. Those just combine to be 0, and then you just have one more term to really work with. So those are really nice and easy for us. All right, let's see here. Positive 8 and negative 14. Subtracting gives me a 6, negative 6n. And the last term, positive 14, stays exactly the same. Again, first term, last term, always the same. So on this section here, part 4, the only thing that was different is we had to create more boxes. So we did a 3x3 grid, which required more multiplication and being careful on our combining like terms. Again, just a form of distributive property, but structured in a graphic organizer form. Multiply, combine like terms. Please be very careful with your variables and your signs, but I think you can do it. All right, be awesome.